Bismillahirrahmanirrahim. Assalamu Alaikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus, National Book Foundation, 6 SSC2, unit number 10, Simple Harmonic Motion and Wave. Today we will discuss SLO base or FBISC requirement according to the new syllabus of the comprehensive question. In question number 10 to 12. In previous part 2 we can solve the question number 6 to 9. Now in part 3 we can solve question number 10 to 12. In comprehensive questions, first of all, 10 questions, derive the formula for speed of wave V relating with frequency and wavelength of wave. In other words, this question is also in the form of write the wave equation, or another form of this question, write the relationship between speed of wave, wavelength and frequency. So answer is same. According to this question, we know that the speed is given by V is equal to S upon T, or simply we can say that speed is equal to distance upon time. So we can write that V is equal to S upon T. In this case, wave distance covered by the wave in one time period T. So is equal to the wavelength that is denoted by lambda. So we can replace, then put S is equal to lambda, distance is equal to lambda and time T is equal to time period T. In equation number 1, then we get V is equal to lambda upon T. So we write that V is equal to 1 upon T multiplied by lambda. We also know that frequency is reciprocal of time period. So F is equal to 1 upon T. Putting in equation, so we get V is equal to F lambda and we write that V is equal to F lambda. Then equation represents the relationship between wave speed, frequency and wavelength. So this is also called a wave equation and relationship between speed, frequency and wavelength. In question number 11, show that frequency and time period of the wave are inverse of each other, or in other words, frequency and time period are reciprocal to each other. So first of all, the frequency and period are inverse function. Because the frequency is high, then the time period is low, or when the time period is low, then the frequency is increased. So we have these two terms are inversely proportional to each other, or simply we can say that these are reciprocal to each other. We write that frequency f is equal to 1 upon t and t is equal to 1 upon f. This relation shows that both are reciprocal to each other. For example, if a wave takes 1 second to oscillate up and down, the period of the wave is 1 second. The frequency is the reciprocal of that, so 1 cycle per second. Simply we can say that because only 1 cycle occurred in a 1 second. So frequency and wavelength are inversely proportional to each other. The wave we get, the greater frequency has the shortest wavelength. Twice the frequency mean half the wavelength. So for this reason, wavelength ratio is inverse of frequency ratio. Then we have the relation. In next question, question number 12, what is ripple tank? And describe its working and use the ripple tank to study the reflection, refraction and diffraction of water wave. First of all, see the ripple tank in diagram and note down the apparatus that used in a ripple tank. Here we can see that in blue shade this is a rectangular tray, or this is also called a rectangular glass tray. Here we can put on a table, and upper these are stands that connecting the lamp and electric motor that vibrating the beams. Now the vibrator is moving. Here wave pattern is shown. Then wave front is below the side and here put below the screen. So that reflect the wave on a screen. Now we can write that what is meant by ripple tank. So explain step by step. First of all, what is ripple tank, and then we can explain the study of reflection, refraction and diffraction of water wave. So we will start ripple tank. What is a ripple tank? Ripple tank is an experimental setup because to the study of two-dimensional. What is meant by two-dimensional? Crust and trough. So characteristics of the waves. So we have write the this mechanism is such as reflection, refraction and diffraction. So in simple word we can say that ripple tank is an experimental setup for the study of two-dimensional characteristics of the wave mechanism, such as reflection, refraction, or diffraction. So, we can explain more about the reflection. What is meant by the reflection? Reflection is a change in the direction of wave front at an interference between the two different media. So we can explain or the rigid barrier or so that they have seen in this diagram. Here we can see that the wave are reflecting from the surface to backbones on its medium. So in this diagram we can see that parallel rays in a gray line. This shows a reflective index or index waves, and in B part we can see that these move to backbones in medium. So these waves are a reflective wave. Similarly, we can see that in C diagram, incident and reflective rays with the angle of incident and angle of reflection. So we have wave front turn in the medium from which is originated. When the wave is run into the state barrier, the reflective wave or original path. This means that when these are parallel and state paths, then backbones to its medium. And this barrier is shows that the angle is parallel and theta is equal to 0. In other wave, we can see in diagram C here barrier in angle wave. So these angle of incident and angle of reflection. But angle of incident is always equal to the angle of reflection. So upright the barrier in the tray that the reflective matter can be seen under the screen. Now we can explain the refraction. What is meant by the refraction? when the wave travels from one medium into another medium, the speed will be changed. This phenomena is called a refraction. Now we observe the refraction in a diagram. Here we can see that in ray diagram these are shallow water. It can be moved from a deep water as a wave front, or in other side we can see that an other diagram deep to shallow and shallow to deep. These relate with the wave equation V is equal to F lambda. So we can explain that occurring in a ripple tank, we can place the thick sheet of a plastic in the tray. So the wave travel from shallow water to deep water, we can observe the wavelength and hence we can calculate the boundary between the depth is straight on, then no change in the direction will be occur. On the other hand, wave crossing the boundary at the angle, so the direction travel does not change again by the equation. And last topic, what is meant by the diffraction? The bending of wave round corners of the obstacle, that is called a diffraction. When two slits are put in the wavefront, then that is bent to the slit or bent to the obstacle. When the wave passing this opinion, this is called a diffraction. Diffraction in a ripple tank generating by the state or the wave that plays to the obstacle. Now we can see in this diagram, and here wave are moving and other side this wave in the wave front. Here we can explain that the separation of comparable to size the wavelength after passing through opening the wave separed out in the direction to turn a circular path. This effect is a greater when the size of the opening is a less than or equal to the size of wavelength is generating, then must be noted that wave or the speed is not affected by the diffraction. So we can say that separation of large obstacle is the wavelength. It can be seen as a central part of the wave that cannot be affected, only the part of wave and the edge of diffraction. So this question is complete. Best of luck in next video.